Friends, welcome to Meki Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement for creating these kinds of technical videos in the public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting a spark of creating these kinds of technical videos. And I would like to thank Almighty for my good health and broad mind. And I would like to thank my friends, followers, my dear students, and subscribers. Today's topic of interest is equation of motion. First of all, I would like to tell what is meant by a motion. A change of a position is called as a motion. Let's say this is a body, it is in the position of X. If a body want to move a position of Y, so this is called as a motion, and the distance is called as a displacement, and the speed is called as a velocity, and acceleration and jerk are the motion parameters involved. The motion parameters are, let you know that it is displacement 1 and velocity and acceleration and jerk and last one vibration. Here I want to give the displacement is the rate of change of position with respect to time is called as a displacement. That is the difference of position x to difference of position y with respect to time is called as a displacement, and the velocity is equal to the rate of change of displacement with respect to time is called as a velocity, where the acceleration is equal to rate of change of velocity with respect to time is called as an acceleration, where the jerk is the rate of change of acceleration with respect to time is called as a jerk. Here we are having three different types of motion. One is translation. The translation which takes place linearly. This is a body, this is body move on a linear direction. So this is position 1, this is position 2. If this body is moving in a linear direction, then it is said to be a linear motion. If a body this is rotate having a center point, this is called as a rotation motion. This is called as a rotation motion. If a body will keep rotating against the center position as well as it will transverse is called planar motion. For a best example of a planar motion, when we are riding a bike or a vehicle in a road, this is a very good example of a planar motion, where if you consider your wheel, it is rotating, it is keep on rotating as well as it moves in a linear position. So it is the best example of a planar motion. So these three are the types of motions involved. Next, we are going to deal with a curvilinear transition and a rectilinear translation, as well as curvilinear motion as well as the rectilinear motion. Here, the rectilinear motion or rectilinear translation is a rigid body. It deals with the rigid body. It moves along a parallel straight line. So this is called as a rectilinear motion. Rectilinear motion. Whereas the curvilinear motion, a body moves along a parallel curve. So this is the parallel curve. The body can either move in this curve or in this curve. So this is called as a curvilinear transition. We all know that the centrifugal pump, centrifugal pump, it is in the pure curvilinear transition. The body, that is a fluid particle which is in the impeller, which is always move in a parallel curves. It is always move along the outward direction due to the centrifugal force. The fluid particle follows a curvilinear path only. Next, have a horizontal straight line motion and vertical straight line motion. If a body moves in the horizontal plane, this is called as a horizontal straight line motion. Our body moves in a vertical plane, this is called as a vertical straight line motion. Next, we are going to deal with the equation of motions. So with this background, I am going to start the curvilinear motion first. The curvilinear motion is the motion takes place in a curved path is called as a curvilinear motion. The parameters involved is first the angular velocity, final angular velocity, initial angular velocity, angular acceleration, angular displacement and time. The equation is omega is equal to omega naught plus alpha into t. Next equation is omega square is equal to omega naught square plus 2 into alpha into theta, where next the theta, this is the angular displacement theta, is equal to omega naught t minus plus half into alpha t square, where I said earlier omega is the angular final angular velocity, omega naught is the initial angular velocity, alpha is the angular acceleration and theta is the angular displacement and t is the time. Next, we have an equation called rectilinear motion, equation of motion for the rectilinear motion. The rectilinear motion, the body moves in a straight line, is called as a rectilinear motion. Here the parameters involved is v as the final velocity, u as the initial velocity, t as the time, a as the acceleration and s as the displacement or distance. Here the first equation becomes u is equal v is equal to u plus at, v is equal to u plus at. Next one, v square is equal to u square plus 2as, and third equation is s is equal to ut plus half at square. Here, if the rectilinear motion is in the horizontal position, if there is a horizontal position, we can say on the ground the s is equal to ut plus of gt square. So this is in the horizontal position, and if it is in a vertical position, if it is goes in the vertical position, s is equal to ut minus half gt square. What it says, towards gravity, which is called positive sign, and away from the gravity, which is called a negative sign. If we throw a ball in upward direction, what it happens, it moves away from the gravity. Therefore, if a body is vertically moving upward, then it is called a negative gravity. Therefore, the equation indicates in the minus direction. When the body is came down on the horizontal floor, it is always having a positive gravity. Therefore, that is plus of gt square. If there is no acceleration of a body, we put e instead of a, we can put g, or if we have a separate acceleration, we can put a. If a body, if a lift kind of thing we have a both acceleration as well as the gravity. Acceleration as well as the gravity. In that situation, the equation S becomes ut plus of t into a plus g. So this equation indicates when number of persons in the lift, it is moving in upward direction, or it will move in the downward direction. With considering the gravity, the lift is having certain acceleration and the gravity is also mine. Therefore, a plus g will come. If there is an acceleration of upward and the gravity is in the downward direction, instead of plus here we put a minus, then the equation remains same. I hope with this I'm going to close the equation of motion. I hope I have given an enough knowledge on the equation of motion. If you have any doubts, please let me know in the comment section. And thank you all. Thank you for your support.